Alright, welcome, ladies and gentlemen, boys and girls. Yeah, I am your worst nightmare. Anyway, yes, making another video. Same crap. Um, arguing against just, crap. Better crap against crap, you could say. Something like that. The lesser crap, whatever. Oh, just yeah, it's just really annoying being on this planet. Anyway, so what? Yeah, so no one's gonna fix that. So you have to grin and bear it and such. Um, so I don't know if anybody has seen this new feature. You know, if you are navigating YouTube with an account, you are blighted by this horrible thing when you click on videos to see the recent videos. They for you, so you don't get to see them in chronological order. And it looks like that's going to force the default. So every single time I go look at another channel's videos, I have to do this extra clicking crap, and it's really annoying. And obviously, YouTube wouldn't do these annoying things if, apparently they're just desperate for money. Um, because the only reason they do the for you thing is so they can engineer, put before you, in front of you, videos they can make more money on. They're more likely to retain you, and that's all they care about, is retaining you on the website. But it's all just such a lie. It's so fake. I saw a commercial on a YouTube video last night, where they're selling some ring that you can give your wife, and it has generic "I love you, wife," "Thank you so much, wife," blah 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 blah. It's just it's so chat GDP kind of thing. Like, let's just write the perfect little statement that will fool whatever 85% of women and make them think their husband actually cares. I mean, it's just it's so bad. I mean, if you're a woman and you get one of these rings, it basically means your husband couldn't care less. It's so impersonal. Anyway, it's hilarious. But what a world. Alright, so to the physics, and it's just as bad. As broken as we are culturally, we are likewise broken in sense of science has turned to absolute shit. I mean, reasonable, rational stuff. It's like society says it's okay to be a thief now, for no good reason. It's decided. Really punish criminals? No, that doesn't. No, that doesn't have. That doesn't work. Of course, it does work. But anyway, it's just so stupid. Yeah. It's like 6 people in the whole country are doing all the crime because they never go to jail. It's just so stupid. It's just really stupid. Anyway, so we'll play some of these crappy, stupid videos trying to prove that their little fairy subject, their little fairy story, their little unicorn physics is correct. So, I haven't seen this piece of shit yet, but of course I'm sure it's another video contrived for something. So, to measure the energy of something, instead of banging into a spring, which is, a pretty reliable way to know how much energy something has, is to figure out how hard it hits the spring. Like, if you wanted to find out how much a football player, how many pounds of energy it could produce, you crash them into one of those little dummy things and, spring loaded, and see what kind of pressure it can apply. You don't do this. You don't bang it into crackers. It's just so stupid. Alright, well, maybe we'll just, we better open a new tab, because then we'll have to click that stupid thing again. It doesn't remember your choice, so every time you go back to the website, you still have to click. No, I want the newest first, thank you. I just hate this planet. Alright, so we have pointless text we have to read. This is a trial experiment. The point of the video is just for the sake of testing something new. No, the purpose of the video is noise creation. Don't do science. Do a bunch of mush, whatever, shit talking, farting, and pretend it's poetry or philosophy and it's well thought out and the work has already been done for you. No, the work hasn't been done. You have to do the work to figure out what the catch is. Okay, so untested crap. Here's some more untested crap. Alright, not to prove or disprove kinetic energy, blah 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 blah.
Alright.
Frankly, everybody wants that. So he put text on the video when he's doing an audio video. Okay, that makes a lot of sense too. Not to me. I guess it was something he figured out in hindsight. I should say this fake crap in front of the fake video I'm going to do.
So I'm going to try out another kinetic energy experiment. I figured that this object might be a good object to measure the impact.
Yes, I don't know why you figure that. Yeah, I don't know. You know the chemistry or the geometry of the foam's matrix and how even it collects energy or something? I don't think you know any of that. How collapsible it is at different rates of absorbing energy.
This is called flower foam. They use it for flower arrangements. The interesting thing is about...
Well, this is really... So he does a whole video and he's going to spend a whole bunch of time talking about flower foam when he doesn't know anything about it. So that's really fun too.
This thing, when you press it, it leaves a mark. You can see how deep it penetrated this into the foam. So it would be interesting to see. So this is not going to be my card.
So, but there has a certain amount of time. Just you dent it further distance, and it gets harder and harder to dent. I would likely suspect that the rate at which it deforms changes the deeper you attempt to deform.
And I'm going to drop over this ramp, and it's going to go through the photo gate. This is going to be the one mass.
The only thing useful about that is that it will measure the velocity, so you know the actual velocity at close to impact.
Going twice as fast. I'm going to let it collide into the foam, and it's going to leave a mark. I've already tried it out. There's a mark. And I'm going to do the same, doubling the mass and half the distance, half the velocity, and then we're going to see if the penetration mark, the pressure mark, is going to be the same or not.
So let's just come up with the wackiest possible ways. Why don't you just actually use some horse shit? Why don't you just actually put a pile of horse shit on the table, because that's just as scientifically valid a way of measuring how far does it go into the horse shit. Oh, look, it's a little face, little eyes, little nose, and a face. It's kind of sad cat. It looks like a little sad cat. Makes me sad. The sad cat.
Not. So let's try it out. I hope it will work. Right, this is going to be the setup. I put a heavy object over here so that the foam can't move when the card collides. To make sure that...
So, and it's a pretty pointy object, obviously, so who knows what that even means. We can't even see the actual detail of the edge is so obscured that we can't even see how sharp the knife is, so to speak. So it makes it even harder. So I don't know exactly why that was his idea. Why didn't he put a piece of a pencil on there, with a cut, nice flat edge? Who knows why? Why did he make this choice? And of course, how much this card yields is going to be another huge factor. We don't know how much flexibility there is in how it's even attached to the car.
The car doesn't lose velocity. So as soon as it goes through the photo gate, it will directly hit the foam. So because if I place this further, it will lose velocity. So as soon as it comes out, it will immediately hit it. So there will be no loss of velocity, or at
Not much anyway. One assumes.
least a minimal loss of velocity.
But we don't know. This is almost a sail, so you can almost make an argument it's going to be some turbulence and whatnot, but whatever.
So what I've done is I have attached a nail to the cart.
Ah, that would have been better. Just cut the end off the nail so there's not a point on it. But whatever.
So that we can see how deeply the nail will penetrate into the foam. So that might be a good indication.
Probably just should have put the nail on the opposite way. Nice little flat end. We've already done pointy things into clay and found, oh yes, there's a geometry to that, but whatever.
To measure the force, the incoming force. So let's give it a couple of shots.
Why? Your results are going to be crap, and so what's the point?
And here I've put some markings on the nail, so that it gives even a better indication of how deeply it penetrated the foam. All right, so this is the one mass going twice the velocity. Okay, so the timing is 0.0786. Believe me or not, I'm not gonna turn the camera every time. So it went about one over the one line a bit. Alright, so velocity timings 0.0785. And show you.
So I'll have to find out.
Over the one mark.
0.785. We have to sit there and remember this or write this down, because you're not going to do any of the figuring for us, or what? Who knows?
Let me show you from above. Alright, let's take it out. Wait, I'm going to take it out. Not really easy to with one hand. Hold on.
Yes,
alright, so it was like,
it looks like
1.5, just between the first and the second mark. Alright, so timing 0.0786.
So the time was somewhere 0.7, you said, something like that. Okay, and it's, a little less than the last time, but whatever.
And let's see. There are 4 markings, so it's
No,
again
it's about the same.
Over the first marking and a half. The timing is 0.0789. Penetration depth seems to be 2.
Well, that's not good. That's a pretty big difference.
Timings 0.079.
And this nail doesn't seem to be going in straight, which I don't know why you didn't fix that. I mean, it seems like going in at an angle is probably a bad idea. The car wants to go flat, and the nail wants to go in, and you're just lifting up the cart, essentially. So, I don't know. Probably not the best.
5. Penetration depth seems to be, whoops. Once again, 1.5. You can see that's the second marking, and there are 4, so it's once again over the half.
A little bit more, so he's gotten from anywhere from a half.
This is like 3 times 1.5, and once we had at the 2 mark. All right. Timings 0.1541. Penetration depth. Right at the first mark.
So is this the heavier car?
Right. Timing 0.1423. Penetration just a little bit further than the first mark. Right. So timing 0.1432. A little bit beyond the first mark. Alright, let's now see what happens when the 2 mass goes twice the velocity.
2 mass goes twice the velocity. So what the hell was that? One, I don't even know what he just did, right? Do you know what he just did? I don't know what he just did. So he got 1.5, 1.5, 2, and then he got 1, 1, 1, 1. I don't know.
Timing 0.0803. Let's see. It's over the second one. Alright, timing 0.0773.
It's
seems like 2.5. Timing 0.0784. 2.5.
So here we have lots of pictures. Okay. I don't even understand what he did, frankly. So he had the first one at, and then he did the second cart going the same speed with twice the mass, and then he did half the mass at twice the mass. I don't know, something like that. I don't know. Oh, there was the picture. Yeah, I'll have to go back to that. Okay, so let's go back to this picture that doesn't say much. All right. So he's not showing the velocity numbers here, so I guess we'll have to just trust the velocities were correct. So 1 mass going 2v is whatever this is, 1, 2, I guess we'll count the ones showing, 3.5. Alright, and then a 2 mass going 1v, so you'd expect that to have half the energy. 1, 2, 3, 4. Yeah. Well, we really can't do it by what's showing. So let's see, figuring that out. So this one went in 2.5, something like that. Well, clearly this two mass going twice the velocity. Why would we do 2 mass going twice the velocity? We do a 2 mass, yeah, okay, twice the velocity, and then a 2 mass going 1 velocity. This is the only one we really want. Alright, so I don't know why this one's in here. But anyway, alright, 2 mass going 1 velocity versus a 1 mass going 2 velocity. And that should be the same momentum. And it appears to be close-ish to the same momentum. 1, 2, 3. This one's a little short. This one's way short. So unfortunately it has that in there. The one where it went 2, you know, the 1, 2, 1 is throwing these results way off. So the 1.5 this was declared to be, and this is, you know, a little less than 1.5 showing here. 1, 2, 3, and that's almost. So not, like I said, pretty unuseful, frankly, as results. Certainly more than 1.4, but less than the perfect. These two images should be the same, because it should be the same momentum. But obviously speed matters for bullets and lots of things, so speed can, you know, cheat. The fact that something hits something, penetration, is really dictated by so many things. You know, whether this thing has a surface, whether it's crumblier on the surface than it is deeper inside. There's lots of reasons why a substance doesn't penetrate evenly. And like even our skin has a barrier, so it doesn't penetrate at all at slow velocities. Because it has a tension built into it. So it's, you know, however you're going to test this isn't, frankly, what I'd say is a very good way to test it. When a spring would have done the job, you just bang it into a spring, and frankly, the two things should weigh the same. Alright. So, just pretty junky. So let's see what they say, the commenters. Another great video. another great piece of experimental data. Yeah, sorry, it's not. All right. Thank you so much for uploading a new video, Dispar. Using the foam is a great idea. So, and why would it be a great idea? That's the question. So he hearted that because it's a great idea. Yeah, I don't know. Why is it a great idea? Why is it better than you could just measure? See, the trick is you have to try to avoid friction as a way of measuring. So you don't want to push something across the surface because friction is uneven. Fast things will go further than slow things. So in a sense, this is still relying to some extent, okay, because it's still in gravity. But anyway, let's see. I saw somebody else do this a few years ago, and he got completely wrong results. So I don't know who this was. Where was this done? Interesting that he sees things that he doesn't show anybody. Yeah, so nobody else. So he saw a kinetic energy experiment a few years ago. I didn't know it was a subject a few years ago. Now, 2 years ago, a couple of years ago, yeah, it was. So anyway, that's interesting in itself. So I don't know why he doesn't, he should try to find that again so we could all see that video. The way of proving whether it is a reliable method is to double check whether it supports the one thing that everyone, even Gary, can agree on. What's that? Namely that multiplying the mass 4x. Huh? why would I multiply the mass 4x? Is also supposed to cause 4x the volume displacement. No, it's not. You don't square the mass in the formula. The mass isn't squared, retard. So where does everybody agree on this? Anyway, I mean, I guess you could say 4x is the sense that, yes, multiplying the mass doesn't do you any good. It just gets you the regular 2-to-1 relationship. So if it's twice the mass, it's only going to be twice the increase in the energy in both formulas. So who cares? I mean, we're trying to find the point is to find the difference between an experiment where mv squared gets a different answer than mv, not ones where they get the same answer. If it doesn't, it belongs in the bin. I've not watched your results yet, Dispar. So he's commenting before watching a fucking 5-minute video. Well, 6 minutes and 19 seconds. Why would somebody do that? Why wouldn't they watch the 6-minute video first? But if it's anything like the test, the last guy who used the same or similar plant pot flower arrangement material. So where is this video? Then there we go. Results are likely to be wrong. Hands up. It's supposed to be heads up, maybe. Hands up. I don't know. So he's claiming the results are likely to be wrong because the other guy's results were obviously wrong for some reason. Okay. I may not watch to find you get perfect results in line with both 2xv and 4xm, which is what is needed for it to agree with all the clay experiments done properly. So again, he keeps saying done properly when they're round objects he's dropping into the clay, and he's not dropping them deep enough for the roundness not to provide a bias. If you don't go all the way into the clay, then one object has to push a lot of flat surface into the clay, and the other one has the advantage of the sloped surface going into the clay. So he doesn't understand that difference. Anyway, i.e. by volume displacement, not depth of penetration, which is what Gary originally wrongly taught us to believe. That's not true at all. All I did was read what was on the internet, okay, about a historical character in the experiments he did. So I didn't do anything wrong, okay, and was the one and was also one of the mistakes the last guy made when using this material. So why doesn't he show us the video? Okay, no, he won't do that. I guess you watched. I mean, he really thinks that the nail volume could possibly be different than the depth in the case of something so small. In the case of something so small, it's just not really possible to matter. And the fact is the head of the nail goes deep enough into the material where the pointy edge can't mean much of a difference, because both objects encountered the same amount of work done, say, by the wedge. I guess you watched his video and decided to give it a go. So isn't that strange? There's another video, and somehow it hasn't been linked to by anyone. Well, I will post this even if I look a fool if you actually test 4x the mass. So I don't know why somebody would do that exactly. And that does indeed support 4x the displacement, equaling 4x the energy. Yeah. 4 equals 4. That makes sense. 2 equals 4. That doesn't make sense. Yeah. I can't believe he's actually making this argument. I don't know what the point of his argument is. I mean, clearly the formula has a square on the v. It doesn't have a square on the m, so that's where the dispute is. All right, here goes. Let's play. So, incredibly useless. It'll be his own reply, no doubt, right? Oh, we can't see the reply. Let's try this stupid thing. No, it's first. I mean, these YouTube features are just so annoying. Okay, it still doesn't. Ah, there it popped in. So you have to hit it 3 times. YouTube is just so much fun. Alright, okay, so I guess you were going to do a different experiment, doubling both M and V. So not so easy to compare with experiments I referenced. Well, at least one of them would be. I think the best way to test how reliable it is as a measure of energy is exactly what I said, though. Simply keep the same V but multiply the mass 4x. So I just can't imagine why he thinks that's a way to test the difference between the two formulas, is by testing the portion that's not squared. The portion that's exactly the same. Test the part that's exactly the same in both formulas. No, that's not the way to figure it out. Okay, so then even Gary would agree that really is 4x the energy. Yes, 4x the mass would be 4x the energy. That's right. If you increase either one of the multiples, if it's 2 times 2 equals 4, well, if I make it 3 times 2, then it's 6. And if I make it 2 times 3, it's also 6. Because none of those are squared. Idiot. Oh, he's just such an idiot. Anyway, if it doesn't cause 4x the displacement, which in this case being a straight nail is about the same as depth, okay, so he's admitting the round ball is a problem. Alright, not so with round ball, yet that really does cause 4x the volume displacement in my clay experiments, including the clay really is a reasonable, reliable, and accurate way of measuring the energy. Yeah, squishing the clay, like in the Mythbusters experiment. That's reliable. Dropping round things into it isn't. Okay. Alright, I urge you to try that and see if it penetrates 4x as deep. Yes, do the experiment wrong like I did, and ignore the valid criticism, that you don't understand that round things have different aspects to their form or shape, and that the two experiments are really testing the different aspects of the shape. They're really not testing, you're not getting to the real point, because the two experiments are testing a completely different property of clay in terms of how you're moving it. In one case you have to move it 2 ways, down and over, and in the other case you just have to shove it sideways, and that's a huge difference. Alright. I mean, I've already been over that. He's not acknowledging the counter-argument or countering the counter-argument at all. So he doesn't think round things, the surfaces on round things are fundamentally different. The bottom flatness isn't different than the side flatness in terms of going through an object. He doesn't think it's harder to go through an object this way than it is to go through an object this way. Yeah, he doesn't think so. Alright. I urge you to try that and see if it penetrates 4x deeper, equals roughly 4x displacement. I don't know what the fuck why is he obsessed with this now? Let's test the M part of the theory. That's the part that doesn't need to be tested. The only point of doubt, if you will, pardon the pun, being that the length of the pointy bit isn't equivalent to any other part of the nail's length. A minor point, but seeing as we are aiming for as much accuracy as we can get, a valid one. So a flattened-ended nail would be more appropriate, I'd suggest. So obviously, exactly, I'd say a flat object in your clay experiments would have been more accurate and appropriate too, idiot. You should have done the same thing, idiot. Oh, I mean, it's just amazing that he sits there. So a flat-ended nail. Why didn't your objects have to be flat? If his are supposed to be flat, why shouldn't yours have been flat? Idiot. Anyway, then thumbs up anyway, mate. So he's pretty down on the whole thing. He's bitching, and then he says thumbs up anyway. Keep making noise. Keep going. I'm dying to see what happens with 4x mass. I just don't know why he could think it's in much doubt. You know, kinetic energy and momentum say the same exact thing will happen, so how is that would be interesting? Alright, should be 4x depth with a flat-ended nail if this is valid. Well, if the substance you're using to measure the energy is valid, you could argue. I'm deeply curious to know. I would think it'd be better just to use a scale. Scales measure weight. Weight is what you're creating. So, I'm sorry you don't understand that part, but yeah, that's really what you're doing. Alright, good for you, Dispar. Doing experiments rather than vomiting vile, idiotic. So this moron is also, you know, there's no point in talking about how bad his sputum is, okay, in terms of what he claims to be a truth, and he claims it based on having no knowledge of the subject at all. So he's not going to defend Leibniz's arguments. He's not going to defend Descartes. He's not going to defend any of the historical references. You know, he's just going to claim it's the truth, and he knows it. Why? Oh, that's right. Yeah, there's no answer. From the cult of self-hatred. Oh, isn't that so cute? When there's absolutely nothing in a statement I ever make that indicates anything like I contain any notion, or I'd even know what a self-hatred is. You know, it's just such a silly accusation to make that something about any element of my philosophy has something to do with self-hatred. No, I tell every person who agrees with me that you're doing marvelously. Yes, you're wonderful, fantastic. You're not an imbecile like this piece of scum. You know, be proud and happy that you aren't them. Now, obviously, the scuzz they've covered the planet in is still unpleasant, so you still have to live on the earth they've covered with their vile bile. But yeah, that's just, you know, unfortunately, that's what life does. Alright, so some pretty unconclusive. He just didn't bother putting any numbers here at all to give us a real clear view. And again, the experiment itself has a little catch in it, in the sense that there was the one way aberrant experiment. Yeah, I guess this is the one full half off, which is, you know, pretty gigantic. So what you can make of that, you know, it'd be better if these results were more consistent, but it just shows, you know, 4 times it works and then the 5th time it doesn't. You really do have to explain that, because that's not good. Anyway, so I guess we'll 26-second video of writing, so that ought to be fun. Might as well. Let's see. Acceleration. So let's see, he asked, what does per second square mean? He should have said per second mean. How can time be squared? P.S. I mean, how can you square time rather than how do you get s squared? Well, what you mean doesn't mean anything. But anyway, because speed is displacement per second, meters per second. Yeah, that doesn't explain why it's squared, right? So that's a pretty dumb answer. Yeah, it's a really dumb answer. Acceleration is a change of speed per second, i.e. meters per second. Yeah, it's a rate. Why would I multiply the rate times itself? Why wouldn't I multiply the rate times how often the rate happened? So no answer there. So it's simply an artifact of the mathematical notation. It's not an artifact, it's a mutation, it's a monstrosity, it's a contrivance, that's the word. It's a contrivance of mathematical notation to attempt to make nonsense fit. All right, rather than a description of any real physical quality. Well, that's the accurate part. It's not a description of any real physical quality. That's right. There is no per second per second. You don't square the rate because the rate could happen any number of times. Squaring the rate, if the rate happens twice, or the rate could happen 10 times. Why would I square the rate? The rate's going to give me the wrong answer. If I square the rate, I'm going to get the wrong answer every time, except unless the rate was 32 miles an hour. Except when I do 32 seconds. Then I'll get the right answer, right? So if I do 32 miles an hour for 32 seconds, then I'll get the right answer using their formula. But every other time I won't. So let's see what else is here. Okay, I guess that's that slide. So this is the other slide. It's not showing. There it is. Acceleration and velocity are both derivatives. Understanding derivatives fully requires studying calculus. So no, it's more bullshit, okay? We can figure out whether something has a velocity. The velocity is changing. Now, if you need to know millisecond by millisecond how much exactly it changed and all this other, no, you don't need any of that stuff to know that when it hits something, it's going to speed. And that's all that matters. What's its speed when it hits something? But in simple terms, it means that the rate of change, how fast the value is changing. So more baby talk. Velocity is a derivative of position, so just more dar. Okay. It measures how fast an object is changing where it is. So what? Yes, we already know what velocity is, speed. Yes, how fast something's going from one place to another place. What's the average? And the acceleration would be exactly the same argument. The acceleration is merely adding or subtracting from a velocity. So it's still a velocity. All right. Acceleration is the derivative of velocity. It measures how fast an object is changing velocity at a particular moment. You could say how fast the object is changing, how fast it is changing where it is. Changing where is. Yeah, well, that's just too silly. You could say that, but people would look at you funny. Haha. A better way of saying this is that acceleration is the second derivative of position. And again, it doesn't mean anything as a statement, because acceleration really is just a change in velocity. That's all it is. It's nothing more. Your velocity change, you call that accelerating. Period. Or decelerating. Alright, if all we have to work with is algebra, we calculate, so algebra is, connected to geometry, which is, there's no geometry to velocity. Anyway, we calculate rate of change by dividing the amount of change by the time it took. Yes, that would be sensible, but you don't do that. You're not calculating the rate of change, right? So that's what I just said. The rate of change by dividing the amount of change by the time it took. That would be sensible, but that's not what you're doing. The units we use show that's what's going on. The amount of change in position is called displacement, and it's measured in meters. Somehow they're saying that displacement is an excuse to square the rate. So the rate of change is calculated by dividing the displacement by the time it took. So again, more nonsense about how this justifies squaring the seconds. That gives a value for a velocity in meters per second, or meters per second. Yes, that's right. So why are you squaring it? Yeah, we haven't gotten to that part yet. To calculate the rate of change of velocity, we divide the change in velocity by the time it took to change. We already did this. the amount of change in velocity measured in meters per second is divided again. Why? By the time in seconds. Why would I do it twice to get acceleration? That would be absolutely idiotic. There's absolutely no reason to divide it a second time by any second units. I already got the answer. I got a rate. It's happening at a certain rate. I've now and I multiply that by how often the rate happens. How often did it do this change in its velocity? That's it. There's nothing more. Okay, I can't really read this. So we get units of ms over s. The u says u. So that's just made up crap. And that can also be written as but there's absolutely no reason to square the seconds. There's nothing about the question that requires the squaring of anything. You're just saying you have a unit of acceleration, an amount. And you're just saying, well, how often did the amount happen? And if you square the amount, you're not going to know how many times it happened. And if you square it and then multiply it by how many times it happened, you're really going to be far off. And that's why they're so far off. Alright, so I don't know if Quora wrote that. I don't even know what the fuck this is. Is that his own statement or is that the Quora statement? Who knows? Alright, let's see. We get something. I don't know if this is worth it. Search. I can't even read this one. It's a little bit faded. It's easier to understand. Instead of meters per second, you talk in terms of miles per hour. Huh? You start at rest. After 1 second, you're going 1 mile an hour. The second, you're going 2 miles an hour. A second after that, 1 mile an hour. You are giving 1 mile per hour every second. That's pretty straightforward and is the way to describe acceleration, but it has nothing to do with explaining why you would square the value, because you're not going to get the right answer by squaring it. The acceleration of 1 mile an hour every second could be written as 1 mile per hour per second. Yeah, so what? 1 mile an hour per second isn't second squared. Those are two different time units. So now you understand that they're two different times. You can't square two different things. Just saying, giving t, so they're using the t and basically saying seconds, or the s. And they're saying the seconds in one equation is the same seconds as in the other equation. It's not the same seconds. They're two different times. Alright, so it doesn't even matter. Alright. Now instead of miles per hour, think meters per second. Okay. Yeah, I don't know why this is so faded. I'll write these as meters a second. You start at rest, and after 1 second, you are going 1 meter per second. Yeah, so if you start at nothing, the acceleration and your velocity are going to be exactly the same number. After 2 seconds, your velocity is 2 meters per second. Okay, yeah. So what? How does that mean I square the seconds? Now, suppose you want to confuse a student. Instead of saying that you're gaining a meter per second every second, you say you are gaining 1 meter second every second. I don't know what that could mean. Then you make it one step more abstract. You say your acceleration is 1 meter per second per second. Yes. I guess. Now, to leave half the class behind, instead of explaining any of that, you simply write 1 meter per second. I don't know why, seconds times seconds, and then you're just saying you're squaring the seconds. Yeah, so this was pretty much a comment saying what I'm saying, which is it's all just a lie. What the hell happened here? Well, it's a better image anyway. It's playing, I guess. Okay, so let's go back to this. So start playing the video. Alright, you can read the per second. The most pause. Acceleration is measured how fast it's changing. Alright. That is an acceleration of 10 miles per hour. Okay, now suppose we express the speed in meters per second instead of miles per hour. Suppose the speed we are increasing 5 meters per second every second. Yeah, but how many seconds is every second? Every second, what does that mean? For eternity? For infinity? I mean, it doesn't mean anything. Okay, then acceleration would be 5 meters per second. Per second. No, it would be 5 meters per second per how many every is. So how much every was, that's what you multiply it by. The every number. Okay, how many? 2, 5, 7 seconds? How many seconds were you accelerating at that rate? That's all that's relevant. And everybody should agree that's all that's relevant. How many seconds did you accelerate at the rate you've given? So you have a unit of time, an amount you've measured. You're saying it accelerated a certain amount in that unit of time, and then you're saying how many of those units of time are there that it accelerated at that rate. So there's no room for squaring anything. All right, well, anyway, this is all just the gibberish they use to evade reality. Okay. All right, so he says 5 seconds times 9.8 meters squared. So the squared is there again. Doesn't mean you have to square 9.8. Of course it does. Well, what does it mean otherwise? There's nothing else it could possibly mean. That's exactly what that means. The fact that it is written as meters per second square is just mathematical derivation. I'm just saying anybody who does the equation is going to solve it by squaring it. The square on the seconds means this number has to be squared. I mean, what are you talking about? In math, when the two variables are multiplied, n times n per second, it can be represented by an exponent n squared per second squared. I'm just saying that exponent is recognized as squared. The squared symbol doesn't just mean nothing. There would be no point in putting it there if it doesn't mean anything. What would it mean if you didn't square the 9.8? What would you do with the square? It doesn't have any function. I mean, it's just so stupid. There's literally no mathematical problem with this, except the fact that anybody solving the problem will square the 9.81. This is constantly being applied in every practical field, so that's a big lie. I mean, this part doesn't know anything about these fields. What do you know about any of these fields? Why don't you show us where the squared is in the formula and nobody squares the number? Show me the benign squared. So show me when a unit is ever squared and it's benign. That means nobody ever uses it to square the number in front of that square. Complete crap. So Gosling's got the baby talk, right? Yeah, that's what it is. Gibberish. Yeah, there you go. So they're fulfilling the destiny anyway. It's hard to believe they could make 5 comments out of this. Is Gary actually denying that acceleration exists? So where did that happen? What I'm saying is it's exactly doesn't mean anything. The acceleration is just telling me how much velocity you have. It's just, yes, the velocity is changing. Okay, well, who cares? I mean, so what? The force only changed it a certain amount. And that amount is just a velocity. It's just a rate. It's just how much speed did you lose. And all you're doing is multiplying the speed you lost. And that's it. Times the mass and you got the answer. Alright. Well, anyway, that's the impression I get when he says or implies it's just velocity. Well, that's all it is. A changed velocity is the same as a velocity. You're going to measure it by measuring velocity. Correct me if I'm misunderstanding his claim. I'm sure you're as shocked as anyone that he can't get past the most basic concepts. Yeah, I can't get past the concept that a rate squared is retarded. Why would it just happen that the event happens exactly the same number of times as the amount of the event? So why would that make sense to you? I am appalled and shocked that somebody could think that makes sense. I mean, you know, I could say I can shoot, my gun can shoot 400 bullets per second. I could say something like that. That's the rate it works at. And so I shouldn't even talk about how many times I did that. I should just say it's 400 squared. That's how many bullets I fired. Why would I do that? It doesn't make any sense. I fired the gun a certain number of times. I didn't shoot it 400 times. All right, even though he's been thinking about them for 10 years or more, perhaps he has a different idea of what thinking entails. Well, see, oh, this is wasted time. You have a pitiful idea what eating entails. Poo eater. And really, all he is doing is endlessly focusing on simplistic ideas. Yeah, the simple idea that squaring a rate is just nonsense. Let go long enough to actually think through the consequence of what I'm saying. Yes, I'm saying per second is absolute, insensible gibberish. Why would anybody ever say such a thing? Any event could happen. Okay, this event, I can make it happen in 1 second. I should square it? It could happen twice. It could happen 7 times. It could happen all kinds of different numbers of times. Why would I square the event? What do I gain by squaring this event in terms of knowledge of anything? It's just meaningless. The event only happens a certain number of times. It doesn't happen a squared number of times. All right. Let's see. Lucky there's only 5 of us weirdos. Yes, exactly. Yes, I think the 5 weirdos have done an astonishing job. So amazing in keeping the second squared propaganda machine running for so long. I'm just saying you're defending something that is, in fact, just absolute nonsense. Again, you can't possibly think that an event that can happen more than once should be described as, okay, per second, when it didn't happen per second. It didn't happen every second. It happened 5 times, not the number, not the weight of the object. I mean, it's just so stupid. Let's see. We all deserve a pat on the back for denying the sheer magnitude of odds against us, keeping the myth alive. But it's exactly how the errors are retained, is you people. You're the great science breakers because you don't apply any scrutiny or any accountability. You let them get away with all kinds of errors and all kinds of misdeeds. So again, for 200 years, Robert Young, what the hell's his name? The Young wave drawing couldn't possibly create a correct answer in the double slit experiment. Okay, it just can't. It's not an accurate description. It wouldn't. His drawing in math doesn't get the right answer, and none of you people could even figure that out. And if it's true, you won't admit it. So I mean, isn't that just exactly how it stays broken? So I mean, you're the real. I mean, there's evil in the sense that other people made mistakes, but here you are telling them their mistakes are fine. Because you're too stupid to see them. So anyway, all gibberish. Let's see. I think these texts are still too difficult for Goofy. I've made a slide. Oh, one of his slides. Oh, it's so exciting. A slide. This won't make any sense. Yes, please leave YouTube. There, that sure proves it. That's why we square it. Yep. Can't get any more decisive than that. It makes perfectly good sense why we square the little A part there in the middle. We square this for some reason. Why? For no good reason, really. It's just a 10-mile-an-hour change, a 10-mile-an-hour change for a certain number of seconds, and that's it. That's all there is. Why would I square the 10? That's right. No reason. All right. I mean, he doesn't... Okay, 2.5 miles per hour per second equals. No, it equals 2.5 times 2.5. Anyway, no point. That's the part you're squaring. So anyway, which there's no reason to do. So it's only a 10. I don't know why he wrote it the way he did. I mean, it's obviously just a 10-mile-an-hour increase for 4 seconds. So all I'm doing is 10 miles an hour for 4 seconds. That's all I have to multiply. And I'll know the force that caused the change. Alright. But shit. No squaring necessary. Okay. So, let's see if there's any commenters, which there aren't any. Wow. Is the video live? I didn't bother to check. Maybe something went wrong. Yeah, I've been here an hour. Alright. Well, we'll go back and see. And we'll do some other crap, I guess. So let's see how many people is here. That'll tell us something. 13. Well, it should be a comment. At least one. 13. Not that bad. Alright. So, there was a relativity comment on the video, one of the videos by whatever, the Virgo guy. Where is the absolute frame of reference? There's no where. It's everywhere. All the absolute frame is saying, if you believe in an absolute universe, is just saying that there's absolutely 3 dimensions. And the space in all the 3 dimensions is legitimate space. And there's no such thing as a framed perspective of some kind. You just have a perspective in 3-dimensional space. And that's it. I mean, it's just a way of saying there's an absolute 3-dimensional spatial universe. Frames mean you don't have an absolute 3-dimensional spatial universe. It's somehow the moon is in some way variably different. It can be a different distance from me, depending on where some observer is standing. I somehow get closer to the moon, or I get further from the moon. That the space isn't absolute. And so you're the one, I think, claiming the extraordinary case, that the universe isn't what it appears to be, which is 3-dimensional real space, and that things are fixed distances from each other. I will never be closer, I'm not closer to the moon or further away from the moon. I'm exactly a certain distance from the moon, and what some observer thinks has nothing to do with it. So that's where the absolute frame of reference is in a logical brain. Let's just put it that way. Okay, the absolute frame of reference is everywhere, but it's especially in logical brains. And why do you choose this frame of reference? Why do I choose a 3-dimensional universe where things are fixed distances from each other? Because in my opinion, every piece of experimental data indicates that's exactly how the universe functions. That the fact that I'm closer to one pen than the other pen has nothing to do with how far apart these 2 pens are. Their condition is not dictated by my perspective. Doesn't have anything to do with it, frankly. Nothing at all. And that they have real fixed positions, and there's absolutely no reason not to believe that's how the universe works. No good reason. No good evidence indicating that any observer can change the distance between the 2 pens. That the observation changes how far away the pens are. Can't do it. Alright. Over the many other equally valid frames of reference. How are they equally valid? I don't understand how your fables are equally valid. So it's like saying, the Washington Monument, belief in the Washington Monument is just as valid as a belief in Red Riding Hood. I don't think there's any, that's even a close contest. I don't see which one of your frames ever proves the non-existence of the fact that you can't change where things are in the 3-dimensional universe. They are in a physical location, and you can't change it by saying, it's a frame. No, you can't. So I don't get your argument at all. Alright, so, yeah, it's nothing here. Yeah, so, we'll go nothing new. I mean, throw faster, LOL. Not going to replay the video to go find out why, good joke, I don't know. Ha ha ha, made a joke. Anyway, I don't know. People do this. They do make references to little pieces of something in a video, and I just don't know if that's very sensible. Just because You know, why would somebody remember every little bit in a video? They have to go back and replay it just to find out what's he talking about. Alright, so I'll give you a couple of minutes, I guess. I don't know if I want to drag this out any further. If there ain't nothing to argue, there ain't nothing to argue. It's kind of a boring video, I have to say, just because the experiment was kind of nothing. Didn't really show anything useful. So we're still just waiting for the simple experiment. You know, prove levers don't work. I mean, so we just wait for somebody to just throw something with a lever and prove that you can't throw the lighter object twice as far out on a lever. You can't throw it twice as fast for some reason. It won't work. I'm going to show when you collect it with a spring that somehow the thing going twice as fast, you verified it's going twice as fast and it weighs half as much. Well, then go ahead and prove that on the spring it doesn't weigh. It doesn't have exactly the same momentum. So half mass going twice as fast somehow doesn't compress a spring exactly the same amount as the full mass going half the speed. I mean, that's the simple experiment we're waiting for, and none of, you know, the five farters of the apocalypse won't do that one for us. I mean, Brozo did do it, but you know, he claims you know, somehow it wasn't really going twice the velocity, and so they always just find a loophole. So even though the results did show the same amount of force was hitting the spring, you know, he claimed that the velocity was wrong, even though no good reason to think it was. So, no chat. There's nothing. Quite unusual, I'd say. Let me just try. I'll just see if I close that. Yeah, there's nothing in the chat. It's surprising that no one has anything. Nothing. Ah, there we go. We have a comment. You have seen the latest Modern Mystic video. He's praising ChatGTP. Whatever. I mean, he's saying people should become religious to escape reality, and that's just fine. So he says lots of things that are really stupid. I mean, I really don't want to talk about them, but in some ways I do. I really should do a live video on the other channel just so I can do some pointless ragging on things, but I don't know. You know, the Mystic is, like I said, she's one of the most well-informed humans on Earth, and it's just really insane almost, you know, that he has this bizarre perspective, you know, that is so nihilistic, and that, you know, that there's nothing to do here. You know, there's nothing to do here but try to find the happy foods to eat or something. It's just it's so retarded. I suppose in some respects he's just mocking the idiots of his audience. He's basically saying to them, yes, I'm basically just telling you life is ludicrous and all you can do is, you know, find something to wank to. But he won't say it directly like that. But I mean, that's all he's saying. So obviously the chat GDP would just be an example of simplifying your duty to just be a member of the Borg. So if somebody wants you to be a member of the Borg, obviously they would just say yes. Ask ChatGDP and it'll tell you what to do, because it'll give you the social answer, the culturally approved answer. But no, I haven't seen the video. He wasn't making videos for a while, so I got out of the habit of going there first thing in the morning. And so I don't see his videos usually until later. I'll watch two, one day and then not see anything, and then, come back to it. I mean, his points are impossible to understand. I mean, he just keeps making a video trying to say reality isn't reality. There is no reality. I mean, what's the point of saying it? It's just stupid. Nothing's going on here. Well, of course something's going on here. I mean, it's just too stupid to tell me what's happening to me. This event is a meaningless event. Fuck you, you're insane. Okay? There's a hell of a lot of meaning between nail in my eye and cupcake. Okay? Those are really different outcomes, and I frankly think it's important that the outcome has as much cupcake in it as possible and as little nail in the eye as possible. So there's certainly something to see here. There's something to be worried about. There's something to be thoughtful of. You should be thinking about this. How do we avoid that old nail in the eye? That seems like a sensible thing to do while you're here. Yeah, the whole deleting videos is... I thought he was deleted the whole week worth of video, because I didn't realize they changed that stupid option on the channel, where it ends up showing you this stupid For You crap. And so I said, oh, fuck it, all his videos are gone. Because the For You first video was like 4 years old or something. And then I said, oh, wait a minute. And I figured it out. It's just another great YouTube feature. Another manipulation, another fake thing trying to pretend to be real, Oh, well, we're doing this for you. Yes, it's just for you we're doing this. When the only reason why Google Tube is doing it is to fucking somehow squeeze a few more dollars out of us. I hate this planet, which means I hate the fucking planet majoritarians have created. Ugh. I mean, I really hate that. I'm almost to the point where I would say that, yes, we probably would have been better off with kings and dictators. Because we would have had a better odds of them actually being educated and sensible. I mean, yes, they'd be egomaniacal crazy fucks now and then, but once in a while you'd have a smart one, where you have no hope with a democracy, because every single time you just lower the lowest common denominator. You just dirty up the intelligence, gets dirtied up with all the compromise with the morons. More compromising with morons is failure gotten written all over that. Let's see. In his latest video, he called you a type 2 intelligence, whatever that means. Well, cool. I'm sure 2 is better than 1 anyway. Yay. Yeah. So, whatever. I mean, he thinks I'm too rude, okay? And the fact is that I am rude. I'm crude. I get to the point. And, he doesn't like that. I mean, I just don't stick my pinky out enough, when I drink my coffee and blah, 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 blah. And he's very sensitive, and so you can't say something like, I think you just farted. He finds that rude. I'm not allowed to say in the room that, I think you just farted. Smelled up the room there with a fart. Something like that. But it really has to do with the fact that I'm calling him out on this nihilism, this stupid, moronic thing that we should use. We should use our intelligence to understand the world and then forget everything we learned. I mean, that's just too stupid. He thinks the fact is that intelligence can never win the war. And so he's just conceding defeat before the war. And he's just telling all the Americans, don't bother showing up for World War II because we've already lost. We can't win the war. We're going to lose, and so you're just going to die for nothing because we're going to lose. And so that's, I think, what he's conceded. That somehow the future cannot be rescued by human beings being smart and talking about all these problems we face, and that we should do something to mitigate, and that means we're going to change the script in a sense. We're going to write the script where we decide to do the right thing and fight the war and we win. He doesn't think we can win, so he's saying, no, don't write that script. Write the, just go with the moron script of failure. Failure will win. So be a failure because failure is going to be a good thing. Something like that. Might as well be a deserter because you're going to lose the war. That kind of thing. Let's. So Merker, I thought you left a comment about something. Oh, you sent me a video, about water tension. What the fuck does that have to do with any of these arguments? So it's just this interesting thing. There's one of the Julius Sumner videos is, he just smashes two pieces of clean metal together and is pointing out how it sticks, okay? And then if he puts a layer of water in there, it sticks even more, the adhesion. And he says it's 2,500 tons squared, something like that. Some sort of preposterous number. Some number so big that it would, if you could just pull on the aluminum itself, it would just rip the aluminum apart. It's so much pressure. And yes, that's the calculated pressure, but that's, of the tension of water. But that just has to do with the strength of atoms, really. So you're just really making an argument about how hard it is to pull an atom apart, and how much energy it takes to pull an atom apart. And then you're saying there's a certain number of atoms in the entire surface. And you're saying, well, if we calculate how hard it is to pull every single atom that's on the surface apart and add all those together, that somehow we'll get a number. And it's just an idiotically insane, silly number because, no, it wouldn't take that much energy to break the aluminum. So, I don't know how much value that has. So, I just don't know how that gets to any part of the kinetic energy theory. Sorry, I just don't get the connection at all. So, I suppose it was an interesting video to some extent. I mean, the more interesting fact is that NASA knows this. In space, if they clean a piece of metal really well, and they, clean it really well so there's no oxidation, and they combine the pieces of metal, they'll actually weld. They'll fuse right into each other, essentially creating a bond that's as strong as the metal itself. Obviously they don't get results that are that perfect, but it's like they can weld, without melting anything. Because the atoms do just combine like they were naturally going to combine. Because there's no oxidation in the way. And it's the oxidation that creates all of the problems with metals sticking to each other. And so that's why it's only in environments where you've burned off all the oxidation, like say when the minerals are in the ground and they're under a lot of heat and pressure, then the gold will stick to the gold, and that's why you'll end up with a big clump of gold, is because the metals of the same matrix are more likely to stick to each other than elements are more likely to stick to each other than to stick to something else. And so that's why you end up with veins of gold and veins of silver, is because as they randomly hit each other, they'll stick to each other if they're not combined with some other piece of chemistry. So if you can heat them so they're all elemental atoms, the elements will tend to stick to each other. The elements, the same element will stick to same element. Now, it's not universally true, but you know. Maybe it's just true of metals. And I guess that would sort of make sense because metals are crystals, you know. And it's probably harder to stick to something crystalline than it is to stick to something that doesn't have a crystal structure on the surface. Yeah, I don't know if that's a good answer either. Because, you know, stuff oxidizes fairly quickly. So obviously oxygen sticks to stuff sticks to metals really easy. So it's probably another common thing of metals that they all oxidize fairly readily. Yeah, it's interesting though, because you know, theoretically you could stick a piece of copper in the ocean, and I guess it would oxidize, but only to a certain depth, and that would be it. But if you put a piece of steel in, it'll keep oxidizing. I don't know why that is. I guess it's another crystal argument. Somehow you can't penetrate the crystals of the copper as easily as you can penetrate the crystals of iron. Anyway, did you ever have a chemistry set as a kid? I think I had one, but you know, it was like so cheap and crappy that there really wasn't anything to it, and I spent like 4 days, and that was it. You know, just wasn't anything interesting in it. You know, they make them kid safe, right? So there's not much to them. Now, what I did have was bottle rockets. You know, that was interesting. You know, the water rockets. And but chemistry, yeah, no, I had the electronics kit as a kid, you know, the 101, and then I got a 501 or whatever it was. You know, where you connect all the little springy things with wires and you know, make a radio or make it this or make it that. So I did have that. That was a great thing, frankly. And there was something else I got that had 3 books that came with it, and they were really good because they explained how you made a microprocessor and how you made a transistor and how you did, you know. So it was really interesting. They were just little pamphlets, but I can't remember what they came with. They came with something I bought, and that was quite interesting. So, yeah, I'm just trying to think of anything I had. It's you know. Did lots of experiments, but they were all just crude ones, you know, stuff you can, you know, we used to do like for entertainment as kids. There was a stream in my backyard, and so you could go back there, and you know, you could throw a hunk of wood in the stream, and then you could have a race, you know, and you throw rocks behind your boat. Okay, and you know, whoever can get their boat down the stream the quickest, you know, wins the race. And so the interesting thing is we're at this, you know, we're learning all kinds of things like, oh, well, don't go into an eddy and try to get into the deeper water because you get more of an effect. And so you're incidentally learning all kinds of physics, you know, just by playing the stupid game. So I have to say that those are good learning experiences, right? Things like that. Playing with fire, you know. I mean, you know. So I guess you don't need a set that actually says, burn a field down. Kit. You can do the kit on your own. You can. You know. Actually, almost burned the town down once, but it turned out okay. I'm just saying nothing got damaged. But yeah, did start a fire that was a little bit too hard to control. And the irony was, this was with a friend who had actually, he was originally from Scotland, and he moved here, and he really became my best friend, and he got blown up in a tunnel in Scotland where there was a gas leak, and him and some other kids were playing with fire, and it blew up, and he got he didn't get terribly burned, just his arms mostly. His one arm, but two of his friends died. One of them got crushed by when the explosion happened. A giant rock that was holding the archway open fell on his friend. I mean, just grisly, horrible. I mean, I was just So it was really interesting to have a friend like that, just because you're just saying, how do you live with that? It's that's certainly a ball of shit. So anyway, and unfortunately, we were almost too friendly, and it's like his parents thought we were going to go homo, and so I think they moved just to prevent us from being friends, which is kind of sad. I mean, it's just another sad commentary on life on Earth. So I only knew him for 2 years, but it's one of those things where we somehow understood each other really well, and so it was just, it was kind of, interesting. So anyway, that's enough of that. But yeah, it is hard. It's interesting just to think of the little moments where something occurred to you, and the ones that really stick in your memory, and all of that kind of stuff, and where they're really, just those little points where you couldn't buy what they were saying. So it's when I first saw that wavy photon thing, I just was like, that's when I realized I can't trust anything these lunatics are going to say, because that's just too silly. There's no way they could actually think a photon is doing all that crap. So they're just crazy and silly. How do they think it works that way? That's just too silly. Another one had to do with radiation, because we actually made little cloud chambers, and you could see the little stuff shooting out. And it just seemed pretty obvious that it's little stuff shooting in directions. I mean, there's nothing waving happening. And there was some other thing that occurred to me because of that. Can't think of exactly what it was, though. But it's just funny how that, some memories are just so... It's almost like they're in color and they're in high definition. They're so rememberable. And then other stuff is always kind of fuzzy. I mean, you knew you were on the left side of the room, and you knew certain things, but you can't be sure about anything. Almost the memory is so fuzzy, and then other memories are just so clear. And you wonder, obviously there was something, my brain was triggered to say, this is important, so it really did remember it, because it said, this is important. Because, you think about how many minutes of the entire year's worth of science instruction you got in that class, and there's only these 2 or 3 moments that you actually can remember. All right. Well, half-minute warning kind of thing. Yeah. Per second squared warning. Yeah, that's right. So it's an infinite warning. The warning just goes on and on. That was just a train derailment in my town. 8 cars full of acetic acid fell off, I guess there's a bridge into Lake Ontario. Well, that's not the worst thing that could happen, right? It's not like it's dioxin or something. So I guess it's bad for the local environment for a short term, but I suppose it'll, it'll sterilize, some portion of the lake for a while. I mean, it wouldn't have any lasting effect, right? I mean, acetic acid probably dissipates into the environment pretty quickly. Frankly, when you see the people walking the earth, it's I'm amazed. Planes don't fall out of the air and trains don't crash all the time because, man, most people seem really dumb. So it's kind of amazing the planet's still spinning. They're so dumb. So I mean, in a lot of ways, things have got. When you consider how many people there are and so few go loony, when we really don't have, crazy houses anymore. They really don't. They really don't do anything to properly care for the mentally ill, and so it's just so surprising that there aren't more of them, frankly. But that's a different subject. So, you have any other factoids you wish to provide? Like, a dog came on my front yard and he took a poo right on my front yard. Yeah, I just mean that's, it's just kind of a bomb. You're waiting for it to go off. And so, it's kind of stupid of society to not realize that, there are these people who are, basically dynamite just waiting to explode. And they're letting them play with matches. But there is a fine line, That's the tricky part, is drawing that line. Because I suppose some people would draw the line and call me one of those loonies. So. But yeah, there's just no infrastructure to, help people in any helpful way. It's always in this obnoxious way. So. Like I said, I'm just surprised there aren't people that are more restrained than I would imagine they would have been with the passage of more time. I mean, it just seems like so many people who are just functioning on such a dim level that you would think they wouldn't be able to manage, and that they would go crazy, but they don't. So I mean, there's a lot of people who are in bad shape, but they don't take it out on society, where in the past I think they did more. They're more likelihood. So it's like there's somehow less. That's probably the wrong way to say it. I'm just trying to figure out whether they're more broken and less dangerous for some reason. they're more broken in a less broken manner. I mean, no, less catastrophically broken. But no, that isn't true either. But it is a kind of ironic when you think about it that people who are incapable of functioning, we let them be homeless, where they have to totally figure out how to take care of themselves. You know, they're supposed to be competent enough to live without any house and heat and all this stuff, and they're supposed to somehow find it. And it's like that's a pretty high challenge to place on somebody who's not functioning well. You know. Okay, well, who knows about tomorrow? We'll see if there's anything worth it. I mean, frankly, it's gotten pretty redundant now, so I might take a pass for a while. Who knows? We'll see how it goes. But there'll be something I perhaps will spur my interest, and so I'll feel the need to talk about it, but we'll see how it goes. It's just getting, there's just no useful counter arguments, and so there's just nothing to argue, frankly. So the other side won't produce anything but crap. Alright. Certainly crap as a theory or explanation. Nothing like that showing up. Alright, so till the next time, and such and so forth and whatnot.